Training of hydrological models, it all starts with gathering relevant data and harmonizing them to make them hydrologically conditioned to be used in a model or any applications, hydrological applications, that we store all the data that we gather in our data store. And then the next natural step is, of course, we choose an outlet for a given catchment. And then in this catchment, we do a pre-scoping in order to understand what kind of catchment we are dealing. If it's a mountainous catchment, it's a catchment with glaciers, catchment with dams, lakes, types of rivers, hydrological properties of the soil that is in the catchment. And after that, we build a data pipeline, input data pipeline to prepare the model ready for training. Next step is to train the models. During the training of the models, the machine learning algorithms, they calibrate the parameters that are trainable. And after the training is over, we validate them. So basically, validation means analyzing if the parameters and the simulations that are created during training, they adhere with the hydrological properties of the catchment and the physical processes that is happening in this catchment, and if different subroutines they have proper weights, different hydrological subroutines they have proper weights. And when we have and this method, this process can be repeated unless we find a good fit of a model. And once we have a well-fit model, next step is to do, of course, a test case where we run the model that has been trained with our weather data set. And finally, the final step is, of course, after test, is to create performance validation matrices to analyze them, to see what works and what doesn't work. And also we have the one internal matrices, like we use multiple different matrices like NNSE, KZE, their different components, percentage errors and everything. But also we want to create matrices that are easy to communicate and are understandable by our stakeholders. And this is where we do produce matrices that is normalized Nassau Cliff Efficiency Coefficient, which is NNSE.